Solutions for quiz 3 for Math 251. We're asked to calculate some derivatives using the definition of the derivative and the difference quotient. So I guess the first thing you need to know is what is the definition of the derivative? And what is the difference quotient? And the answer to those questions, well, I guess there's a couple answers. It's this mess that I'm scribbling down here. Or at least this is how you find it. Note that they're equivalent. They both tell you f prime of a. They both tell you the slope of the tangent line to some curve f of x at some point a. Both tell you that. There's different ways of coming up with it. So I ask you to do some questions. I ask you to find f prime of a using the definition of the derivative. Well, here we go. Here's f of x. So you're basically just plugging everything in. F prime of a is equal to the limit, as x approaches a, of f of x, given to me as the square root of x plus 1, minus f of a. Well, if f of x is the square root of x plus 1, f of a would be the square root of a plus 1. You're just replacing all the x's with a's. That's divided by x minus a. It's this. Evaluate this limit. Sure, I guess I'll do that now. The trick for evaluating this limit is you see square roots. Anytime you see square roots, think multiply by the reciprocal. So I'm going to multiply the top and the bottom, this expression, by the reciprocal of the numerator. So in this case, the square root of x plus 1 plus the square root of a plus 1. I get here. So what's that equal to? Well, let's see. This is the limit as x approaches a of, if you FOIL out the top, the square root of x plus 1 times the square root of x plus 1 is just x plus 1. This times this is the same as this times this, except the signs differ, so those cancel out. The outer and the inner cancel out. Then the last is the square root of a plus 1 times the square root of a plus 1, which is just a plus 1. So the top boils down to just x plus 1 minus a plus 1. And the bottom, it's this x minus a that you want to get rid of. So I don't recommend distributing that x minus a or multiplying that to this mess, because I kind of want to keep it separate, because I'm hoping it'll cancel out. I'm hoping I can get an x minus a out of the top. You might already be able to see that, in fact, that's exactly what you have up top. If you combine like terms, if you distribute this negative through the parentheses, you get x plus 1 minus a minus 1. Plus 1 and minus 1 cancel out. You're left with just x minus a on the top. And on the bottom, you got all this same mess. And I'm a little low on room here. Shouldn't have put these formulas right here. But that's okay, because I'm almost done. X minus a, those cancel out. That's awesome. Because now all I'm left with is the limit as x approaches a of 1 divided by the square root of x plus 1 plus the square root of a plus 1. This is a limit I can evaluate. I can change all my x's into a's. If I did, I'd get 1 divided by the square root of a plus 1 plus the square root of a plus 1. In other words, 1 divided by 2 of these square root of a plus 1 things. Something like that. Okay, hardest part, probably the algebra. If you can set this up, it's going through all this algebra that's kind of tricky. Now let's do it again. Let's do it again several times. Find f prime of 3 using the difference quotient. This will be similar. I should probably switch colors. It's going to run together pretty bad. Let's go over to red, since apparently my difference quotient is in red. The difference quotient tells me that f prime of 3 is equal to the limit as h approaches 0 of, should I write it out? Sure, I'll write it out. Of f of a plus h, my a being 3 in this case, minus f of a, again my a being 3, divided by h. Okay, the limit as h approaches 0 of f of 3 plus h. Well, f of x is the square root of x plus 1. So f of 3 plus h would be the square root of 3 plus h plus 1, aka 4 plus h. F of 3 would be the square root of 3 plus 1. 3 plus 1 is 4. So what I get is this is equal to the limit as h approaches 0 of the square root of 4 plus h minus 2 divided by h. That should look familiar. That's something we did in 2.3. Evaluating this limit, I'd like to just change all the h's into zeros, but I can't because I get 0 over 0. So multiply the top and the bottom by the reciprocal. That's the trick we do when we got square roots. 4 plus h, square root plus 2. Square root of 4 plus h plus 2. If you do that, things will cancel out nicely. We'll get the limit as h approaches 0 of 4 plus h minus 4 divided by h times square root of 4 plus h plus 2. 4's cancel out, so I'm just left with h over h times 4 plus h plus 2. Cancel out the h's. Then all I'm left with is the limit as h approaches 0 of 1 divided by the square root of 4 plus h plus 2. Can evaluate this limit. I can change all the h's into zeros. I get 1 divided by the square root of 4 plus 2, which is 1 divided by 2 plus 2, which is 1 divided by 4. All right, God, I hope this is it. Oh, I gave you 2 problems. Man, that's a long quiz. I better give you half an hour for this one. Find g prime of 2 using the definition of the derivative. All right, g of x is 2x squared plus x plus 1. Man, that's going to be a long quiz. Maybe I'll only have you do 2 of these 4 instead of 3 of these 4. Okay, so the definition of the derivative tells me that g prime of 2 is equal to the limit as x approaches 2 of g of x, which is given to me as x squared plus x plus 2. Is that what I said? 2x squared plus x plus 1 minus g of 2, which would be what? 2 squared is 4 times 2 is 8 plus 2 is 10 plus 1 is 11. Divided by x minus 2. In other words, it's the limit as x approaches 2 of 2x squared plus x minus 10 over x minus 2. It's the limit as x approaches 2 of, factoring out the top, maybe I'll do that, hide it somewhere. Let's do it down here. Let's factor 2x squared plus x minus 10. There's a few different ways you can do this. One way is first find 2 numbers that multiply to negative 20 and add to positive 1. And those 2 numbers are positive 5 and negative 4. And then replace the 1x with positive 5x and negative 4x. It's not factored, but now you have 4 terms and you can factor by grouping. Greatest common factor in the first group is x. That's not an x. If you factor out an x, you're left with 2x plus 5. If you want to be left with 2x plus 5 over here, you better factor out a negative 2. So what that tells me is this factors into 2x plus 5. If I factor that out from both terms, then I'd have x minus 2 left. So what I'm saying is the top here is really just 2x plus 5 times x minus 2 divided by x minus 2. These x minus 2's cancel out, so really all I'm trying to do is evaluate the limit as x approaches 2 of 2x plus 5. The limit as x approaches 2 of 2x plus 5 is 2 times 2 plus 5. 4 plus 5 is 9. That's the answer to the question. Find g prime of a using the difference quotient. All right, so g prime of a using the difference quotient, I'd say it's the limit as h approaches 0 of g of a plus h. I'm going to write it. G of a plus h minus g of a over h. G of a plus h, well, g of x is 2x squared plus x plus 1. So g of a plus h would be, let me put my limit in there, 2 times a plus h squared plus a plus h plus 1. 2x squared plus x plus 1. Minus g of a. G of a is 2a squared plus a plus 1. And I want to subtract that entire thing and then divide by h. Looks overwhelming, but I think things, well, I know things will cancel out relatively nicely. If we expand everything out, a plus h squared is a squared plus 2ah plus h squared. If I take that 2 and distribute it through, I get 2a squared plus 4ah plus 2h squared plus a plus h plus 1 minus 2a squared minus a minus 1. That entire mess divided by h. It's the worst it's going to get. I got 2a squared here. Maybe I need a color. Let's use red. I got 2a squared here and a minus 2a squared here. How convenient. I got a here and a minus a here. That's great. I got a 1 here and a minus 1 here. Also great. So let's see what's left over now that I've canceled all that stuff out. I got a 2h squared. That was this guy right here. I got a 4ah. That's this guy right here. And I got an h. And that whole thing is divided by h. Factor out an h from the top and cancel it with the h in the bottom. And what you get is the limit as h approaches 0 of 2h plus 4a plus 1. You can evaluate this limit. You can change all the h's into zeros. If you do, this will be 0 plus 4a plus 1. In other words, it'll be 4a plus 1 as our final answer. Oh man, all right, that's finally the end of the first page. I'm definitely gonna have to shorten this for you guys. Sketch an approximate graph of the derivative of the function shown below. It may help to add a scale. All right, so this picture, I just pulled it off Google, didn't have a scale. 1, 2, 3, 4. -1, -2, -3. Sure, there's a scale. Your scale may differ. I don't really care what you use for your scale. Just if you use a different scale, your answer will look slightly different. Okay, so I want to draw something, and I want the height of the thing that I draw to represent the slope of the tangent line to this curve at that point. So what I'm saying is, note that at this point right here, the slope of the tangent line is 0. It's horizontal. What that means is that this derivative, this graph that I'm going to draw, better go through this point. Similarly, the slope of the tangent line right here is 0. So my graph better go through here. So I know it's got to go through those 2 red dots. What does it do the rest of the time? Well, it starts out going down. Right, we're decreasing here. At what rate is it decreasing? It looks like a little bit less in absolute value than -1. What I'm saying is it's a little bit above -1 here. So I'm going to start right around here, around -1. And I'm going to start by having it relatively flat because it looks like the slope stays the same until we get over here. So the slope is the same all the way over to here. And then it starts decreasing faster and faster and faster. In here, it's got a pretty steep slope. In here, the slope looks to me to be -2, -3, something like that. So what I'm going to do is I'm going to have this thing go down and get all the way down to -3 or so. And then it continues to be really steep, so the height stays at about -3 until somewhere in here it starts to get less and less steep. So somewhere in here it starts to get less and less steep. It happens pretty quickly, so this gets higher until it gets to this point where it's 0. So I'm going to draw that a little bit neater. Graph will look something like that, very roughly speaking. I think I like my first picture better. Good enough. And then what happens? Then it starts going up. It starts going up pretty steep. How fast is it going up here? I don't know, a little more than 1, maybe 2-ish or so. So it starts going up, and it gets to a height of around 2. And then it starts to level off a little bit. So it starts going lower and lower. So what I'm saying is the height of this derivative gets up to about 2, and then it starts going back down until it gets to this dot. And then what happens, it starts going down, but just barely. So it gets negative, but just barely, so it looks something like that. Say my answer in red, roughly speaking, will be the answer to this question. Anything close to this will work. Key things to make sure you hit are basically just that it goes through these 2 points, and then some idea about the order of magnitude, about how high up and down it goes. Anything close to this, you're good. So we'll call that good, and that's the end of the quiz.